Day 39 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem, day 39. I hope you guys are keeping up. Part of this channel is to learn. I want to help you guys learn, and we all learning together. We're trying to learn Swift and grow this Swift community. However, another part of this channel is for motivation purposes. I'm trying to motivate you guys to keep going and keep coding every day. There's no need to stop. It's all about discipline. We have to stay disciplined. One thing about me, I code even when I don't feel like it. And that's what I want you guys to understand and to practice. Practice that discipline of coding even if you don't feel like it. Getting those reps in, learning something new every day. Now, with that being said, guys, you already know. Bring your mouse, take your mouse, bring it over here, and go ahead, click that subscribe button, guys. I'm trying to run these subscriptions up. I need you guys' help to do that. I need you to like, comment, and subscribe. Go ahead, drop one of those bank emojis in the comments. All of my bankers out there, drop a bank emoji in the comment. We're trying to run this engagement up and build this Swift community, guys. The Swift community is still in the beginning stages, and we're doing our part to help it grow. So tell a friend to tell a friend that we're doing LeetCode every day in Swift. Come join the page, like, comment, and subscribe. Okay, now with that being said, let's see what question we have here today. Today we have question number 2352, equal row and column pairs. Difficulty level is medium, but you guys already know we're not going to let the difficulty level deter us, and we're still going to keep the solution as simple and easy to understand as possible so everybody can learn and we can learn something new today. So let's see what the question says first. It says, given a zero-indexed nxn integer matrix grid, n times n integer matrix grid, return the number of pairs Ri and Cj such that row Ri and column Cj are equal. A row and column pair is considered equal if they contain the same elements in the same order, i.e., example, an equal array. Okay, guys, so let's see what they're talking about because we're dealing with grids now. I believe this is the first grid question on the channel, so I understand how that might be confusing. So let's look at example 1 and see what we have here today. So today we have example 1, the input grid equals, so this is the grid, but they have it broken down right here. Each row is broken down right here. We have 321, 176, 277. So these are the rows basically. These are the rows, and you get the columns right here. It doesn't list the columns in the input, but the columns are right here. We all know how rows and columns work. You put one row on top of another row, and now you have a column. So these are the 3 rows, and these are the 3 columns. So the output is 1. The explanation is there is 1 equal row and column pair. Row 2 and column 1, 277. So let's see what they mean. So let's go to row 2. Remember, these start as zeros just like an array. So it goes row 0, row 1, row 2. So we want row 2, which will be right here, which is 277. You see, row 2, 277. And we want to find an equal column. Oh, look, it tells us right here, column 1. So remember, go 0. This is the 0 column, 1 column, 2 column. We want column 1. So if you look at column 1, it also goes 277. And you look at row 2, it goes 277. So that's why we call them an equal pair. And there's only one example of this in this whole grid. So row 2, which is this right here, the bottom row, and column 1, which is the middle column, they both equal 277. From left to right and from top to bottom, 277. That's why the output is 1. So let's look at example 2. It has a little bigger grid, but hey, we're not going to let that stop us either. It's just going to give us a better understanding of what we're trying to do. So in example 2, it says the grid is, so remember, these are the rows. We have row 0, 3, 1, 2, 2. Row 1, we have 1, 4, 4, 5. Row 2, we have 2, 4, 2, 2. And row 3, we have 2, 4, 2, 2 again. So remember, this is row 0, this is row 1, this is row 2, and this is row 3, right? The output is 3. There are 3 equal row and column pairs. So let's go through these equal row and column pairs so we can see and really understand what they're asking. So first they tell us row 0 and column 0 are an equal pair. So let's look at row 0 first. Row 0 is this one right here at the top, and it is 3, 1, 2, 2. Okay, so that's the first row, and it's equal to column 0. So row 0, 3, 1, 2, 2. Let's check column 0. It's 3, 1, 2, 2. So as you can see, this row and this column are equal. They both are the same and have the same elements. So that is one pair right there. So boom, we found the first pair. Let's look at the second pair. Second pair, row 2, column 2. So row 2 would be, where would row 2 be? This would be row 2 because it goes 0, 1, 2. So row 2 would be 2, 4, 2, 2. And column 2 would be, this is 0, column 1, column 2. So column 2 would be 2, 4, 2, 2. So if you look, row 2 is 2, 4, 2, 2, and column 2 is 2, 4, 2, 2. So that's another equal pair that we found. So we're going to add that to the last one. So now we found 2 equal pairs. But remember, the output is 3. So there's one more equal pair we had to find, and that is row 3 and column 2. So if you notice, row 2 and row 3 are the exact same thing. So we have 2, 4, 2, 2, and row 3 has an equal column 2, just like row 2 did. So 2, 4, you go row 3, 2, 4, 2, 2. Then we come over to column 2, and it's also 2, 4, 2, 2. So those are our 3. That's why the output is 3, because those are our 3 equal row and column pairs. So now, you guys might think this is going to be a little difficult question, but the solution is actually not that difficult at all. So don't let these big grids or new grids that you've never seen before, don't let them deter you, because the solution is actually not that difficult. So let's figure out how we're going to do this. First thing we're going to do is we're going to say let freq equal grid dot reduce into, I'm going to reduce it into a dictionary, which is going to keep count of each element that we see in the, it's going to keep track of each element we see. Then we're going to come over here, we're going to say $0, then we say $1, comma, default 0. Then we're going to say plus equals 1. Then we're going to come down here and we're going to say var result equals 0. So this right here, this is going to keep track of our rows right here, and it's going to keep track of each element and how many times we see that element in the row. Then we're going to come down here and we're going to say for I and 0 up to grid.count. We're going to come down here and we're going to say let column equal grid dot map. Then we're going to say $0 index I. So that is basically going to loop through each row and find us the ith element in that row, which is going to help create the columns for each row, because it's going to go through each row and find the ith element. So it's going to go through row 1, find element I, then it's going to go through, or it's going to start at row 0, find element I, then it's going to go to row 1, find element I, then it's going to go to row 3, find element I, which will create our columns. So for example, if this is element I, say element I is the first index, right? Going to go through the first row. This the element I. Then we're going to come down here to the second row. This the element I. Come through the third or the second index to the second I, or to I, which is 7, which is going to create the column. So then we're going to come down here and we are going to say if let count equals freak column, then what we are going to do is we are going to say result plus equals count. Then we're going to come down here and we are going to say return result, and let's run it. What does it say? Oh, we have a typo. That's my bad, guys. That is my bad. So let's run it one more time. Fingers crossed. Boom. Now let's submit it. It's already accepted. Let's submit it. See what that runtime is looking like. All right, guys. 346 milliseconds beats 91.11% of users with Swift, guys. Not too shabby. Not too shabby at all, guys. And until tomorrow, I'll see you guys then. I hope to see you there. Hope to see you back on this page. And I'll see you guys then. Peace.